Hi everybody. So now I'm going to show you how to create your chi-square test of independence using your data. And this time I'm just using my qualitative data. So I'm using the columns, what is your gender, and favorite kind of ice cream. And so see that I made just by hand, you can also use a pivot table to do this in Excel, is I made a 2 by 2, a contingency, a two-way table that had my gender as my rows and my favorite kind of ice cream as my columns. In my fake data, I only had 3 kinds of ice cream that people chose. And I identified, these numbers just by counting up. And then I have a total row, you can see here, and I also have a total column. Make sure that that grand total does add up to the number of surveys that you did, meaning it should say 100 there for you. For me, I only had a sample of 20 surveys. You can see I had the first row is my names of my columns, and then I had following that 20 rows of data. So what I did with this data is I copied it into StatCrunch. So I'm going to go over to StatCrunch now. Please notice how I did this. It's really important, or else StatCrunch won't work correctly. Your first column, var1, has to have the names of the rows of your data. And then across the top, you can change the names of these labels here of the columns. And I changed the second one, the second column label to chocolate, the third column label to strawberry, and the fourth column label to vanilla. And then I also typed in the data here. All right. So this data matches what I have in my Excel spreadsheet. So I'm going to click on Stat and go to Tables, Contingency with Summary. Okay, so with summary, meaning that it's expecting a 2 by 2 or a two-way table here. It's actually a 2 by 3, 2 rows, 3 columns. My column I will choose will be chocolate, strawberry, vanilla. I'm holding down the control key to choose all 3 of those because that's where my data is. Those are my 3 columns of data. The row labels are in the column var1. The row labels are male and female. And then by default, chi-square test for independence is what is chosen here. Click on compute, and it's going to give you some interesting information. So here's how your table looks. So it's kind of a check here you can do to make sure that you typed in the data into StatCrunch correctly. Just look and see, what does it give you here? Does what it give you make sense? Okay, and does it look like what's in Excel? And then what does it give you? It gives you your test statistic right there, and it gives you the p-value. So we have a test statistic, and if you'd like, you can just cut and paste this into your project. That's perfectly fine. And that's actually what I did. I'm going to make this Word document available to you. And oh, I didn't do that yet. Let me go ahead and do that. So let me cut and paste it. I thought I had. So I'm just going to use my snipping tool, or you might have another tool that allows you to just cut and paste. I'm not going to include that those last lines there. They're just warnings, and you may not see them because you have so many more data values than I did. It's just a warning that some of these numbers are very small. And when it has an expected count of less than 5, that it makes the chi-square test suspect. That's what it's saying, that it's not sure if the results are believable. Mine is a fake test. It's just to show you how to do this, so it's fine. So I'm going to save this. Let me just save this data to my class project, and I'll call it my chi-square. I think I have it already. I do have it there. So let me just cancel. Thought I had copied it. So let me go ahead now and paste it into my Word document. I'll put it right there, and I'll insert it as a picture file. Let me find it. And there it is. So I'm going to go through all of my 5 steps, my 5-step method of hypothesis testing. So here is for my project, I want to run a chi-square test of independence to test in my project, excuse me, if gender is independent of ice cream flavor. And I'm going to choose alpha equals 0.05. You can model this exactly like I have it, just with your data. Yours will be different. Yours may not be gender and it may not be ice cream flavor. It may be 2 different qualitative sets of data. Since I'm saying I want to test if gender is independent of ice cream flavor, that is automatically going to be my null hypothesis, and that's where the claim is, because that's what I'm claiming. That's what I'm testing. And then I'm going to have my alternative hypothesis will be that the row and column variables are dependent. So as it says here, the problem should identify the claim, what is being tested. For a project, we need to determine that. So we're saying we are claiming that gender is independent of ice cream flavor. So the next step would be, so the 5 steps of hypothesis testing, there's step 1. Step 2, find the critical value or values. We only have one critical value, only one on the right side for chi-square. It's only a right, it's always a right-tailed test. Let me just type this in here. There we go. So we have a table that we use. We need 2 pieces of information. We need the degrees of freedom, which is going to be the number of rows minus 1 times the number of columns minus 1. And that's just data rows or data columns, not including the total columns or the total column or the total row. So in my case, R is equal to 2 because I think I calculated this wrong. So let me fix this. So R is the number of rows. I had male and female. So R is equal to 2. There we go. And actually, let me bring up my table to show you again. I had 2 rows, male and female. And then my number of columns is actually 3, not 2. So column C is equal to 3. So I'll have 2 minus 1 times 3 minus 1. So 1 times 2 is equal to 2. And we're going to have to rewrite this because it's not 3.841. Let's look at the table and let me show you how to read this. So I'm going down to the chi-square distribution table. The area to the right of the critical value is 0.05, so it's this column right here. That's all of alphas in the right tail. And then the degrees of freedom was 2, so I'm looking at this blue row here and matching it up with that column that's 0.05, 7.815 is what it looks like. So let me go ahead and write that here, 7.815. That is my critical value. So how it works here is that we have our chi-square distribution is skewed. It's skewed left, and it looks like this. Skewed right, not skewed left, my mistake. So skewed right, the tail is on the right side, the high part is on the left side. We have 0 right here, and then the chi-square values, chi-square looks like this. It looks like a fancy X in Greek. It's a Greek letter chi, and it increases as you go to the right. My pen's not working too well. Let's see if I can undo some of that. I'll erase it. Okay, INC are increases. Sorry if it's kind of messy. And we're going to have the critical value, and we're going to compute the test statistic, which we did already. And we can just use our critical value method and compare the test statistic to the critical value. So our critical value, 7.815, is right there. And then let's look at our result. So our critical value was 0.31. Right here. And that's our test statistic. Sorry, not our critical value, that's our test statistic. I'll call it test chi-square. And you can see it's way over on the left side. The area in the tail region is the rejection region, as we've seen in chapters 8 and 10. And the area in this case, on the left side, the large area, is the fail to reject region. So let's come down now to our critical value method. Trying to get out of this mode. Let's see. See if you can let me type now. Just 1 second. There we go. Okay. So now let's compare the test statistic to the critical value. So the test statistic again was 0.31 right here. And it's less than the critical value, which was 7.815. So if the test statistic is more than the critical value, we reject the null hypothesis. Why? Because we're in this rejection region. But it's less, so therefore we fail to reject the null hypothesis. Okay, means we don't reject the null hypothesis. And what would we cross out if we look at our hypotheses? We're not rejecting the null hypothesis. We would cross this guy out. There we go. You notice that the claim is still there? So it makes sense. We could use the p-value method. We do have the p-value. And let me just talk about it. So we would get the same result because the p-value, I think I'm typing on subs in lowercase. Let me see if I can just grab this and copy it. There we go. And let's color it in red because I'm going to actually put in the numbers. So the p-value, which is 0.8559, it's the area from the test statistic to the right. It's definitely greater than alpha because remember alpha was 0.05. And because it's greater than, we fail to reject the null hypothesis. Same conclusion, or so I should say decision, that we got from the critical value method. So that works good. So then here's my conclusion. Color this in red. Oops. Red there. So we did not reject the null hypothesis. The claim is still there. So there is enough evidence to support the claim that gender and ice cream flavor are independent, as we would expect, right? Just because it's kind of logical that just only females like vanilla, it's not true, or only males like chocolate, not true. These are independent. So there's our conclusion. So that's what you have to do for your project. And then let me bring up the project assignment. So you run the test, there you go. You can claim either the null hypothesis or the alternative hypothesis, your choice. I chose to claim the null hypothesis. And then don't forget about the discussion paragraph to discuss for each part of the project whether the work that you did in the contingency table and the chi-square test of independence, if they should support your overall project. All right, bye students. I hope this helps you.